Okay, in this video, we're going to be talking about compound inequalities. So a little bit more complicated inequalities. And a compound inequality would be two or more. Sometimes you might have more. Two or more inequalities graphed on the same number line. And these inequalities will be joined by either the word and or the word or. And let's talk about, and you know from basic English skills what the words and or mean, but let's talk about that in a little bit more in depth. First off, the word or. Type 1, the or statements. Okay, if you look at this, this compound inequality that we have graphed here, you have x could be any of these values down here. So that would be x could be any value that is less than or equal to -4. Or you've got these values over here on the other side that x could also be. So this is a prime example of what you would have for an or statement. X could be any of these values, or x could be any of these values up here. That would be written as x could be less than or equal to -4, or x could be any value greater than 1. Now, in interval notation, let's show you how to graph this compound inequality. These would be any value from -infinity, never include infinity, up to -4, and we're including -4. And in the place of this or symbol, in mathematics, the word or can be replaced with a union symbol. We're going to unite these two sets. The U stands for union, so we're going to put the two sets together. We're going to unite them. Any value from 1 to positive infinity. So there you go in interval notation. So now to solve or inequalities, we're going to use the same principles we used in the last lesson. To solve an or inequality, solve each part. We're going to have two or more inequalities to solve. Then we're going to graph on a number line to show the solutions. Okay, number 1, let's solve some or inequalities. Number 1, we're going to get rid of +4 by subtracting 4. You have 3x is less than or equal to 6. Divide by 2. You have x is less than or equal to 2. Or you have a second part. We're going to get rid of 5 by dividing by 5. You have x is greater than 9. So here's your solution. Now let's look at the graph of that to see, okay, x could be any value less than or equal to 2. That'd be any of these values. Or, again, think about it, anytime I give you the word or, I'm giving you options. Think about the word or is as you have options. It could be one thing or it could be something else. X could be any value smaller than or equal to 2, or x could be any value greater than 9. So it could be any of these values over here, or x could be any of these values over here. Now, in interval notation, that would be written as x could be any value from -infinity up to 2, inclusive, or the union, x could be any value from 8 to infinity, not including 8. Number 2, to get a +6, we're going to subtract 6. That gives you n is less than or equal to -1. Or subtract 7, that's going to be 9n is greater than 36. Divide by 9 will be n is greater than 4. So n is either these values, or n could possibly be these values. So n could be any value less than or equal to -1. So or equal to or less than. So n might be any of these values, or n could be any value greater than 4. So open circle shaded to the right. So that would be n could be any value from -infinity all the way up to -1, inclusive, or n could be any value from 4 to positive infinity, not including 4. Number 3, move your 8, gives you -3y. We're going to subtract 8 is less than or equal to -15. Now remember from last lesson, anytime you divide by a negative, we're going to have to flip this symbol over. So we're dividing by -3 and we get 5. Or Move your negative 3 over by adding 3. That gives you 10y is less than or equal to negative 30. We're going to divide by 10. Now dividing by 10, that is not a negative, so you do not flip your symbol. So here's your answer. Y could be any value greater than or equal to 5, or Y could be any value less than or equal to negative 3. So any value greater than or equal to 5 would be these values, or any value less than or equal to negative 3 would be any of these values. Written in interval notation, that would be any value from negative infinity up to negative 3, including negative 3, or any value from positive 5 to infinity. Number 4, move the 6 first. You're left with a negative 2a is less than. To move 6, we're going to subtract it. You're left with 2. Since you're dividing by negative 2 to get rid of this negative 2, you're going to flip your symbol over and you have a is greater than negative 1. The other one, to get rid of plus 1, you're going to minus 1. You now have a over 2 is less than negative 3. To get rid of 2, since it's division, we're going to multiply and you get a is less than negative 6. You did not multiply by a negative, so therefore do not flip your symbol. So there's your two statements. A is either greater than negative 1. So here is negative 1. So a is either these values, or it could be any value smaller than negative 6. So it could be any of these values. So a is either the values from negative infinity or up to negative 6, or it could be any value from negative 1 to infinity. And I might ask you a question on the test, something like, well, could a be 3? The answer is yes, because that's included in this interval. Could a be negative 7? Right there? Yes, that's in this interval. Could a be negative 3? No, because that's in part of the interval that is not included. Number 5, distributive property 15. Actually, let's do this one a little bit different to save ourselves a step. Instead of distributing, since 3 is being multiplied by everything, mark it out and divide by it. Gives you 5 minus 2k is less than negative 4. You did not divide by a negative, so do not flip it. Let's move our 5 next by subtracting. Gives you negative 2k is less than negative 4 minus 5 is a negative 9. So therefore k, we're going to have to flip our symbol because we're going to divide by negative 2. Negative divided by a negative is a positive 9 halves. So there's the first part of our answer, which, by the way, that would be k is greater than 4.5 if you want to write it as a decimal. The other part, same thing. To get rid of this 1/3, instead of distributing, you can actually divide the other side by 1/3. To divide by a fraction, you flip and multiply. So that's the same thing as times 3. So that gives you 15k minus 9 is less than or equal to negative 9. Move minus 9 by adding, gives you 15k is less than or equal to 0. Divide by 15 gives you k is less than or equal to 0. There's the second part of your answer. So k is either greater than 4.5. K could be any number larger than 4.5. So come in here to 4.5, put an open circle and shade to the right. Or k could be any value less than or equal to 0. So there's your two options for k. So any number from negative infinity up to 0 inclusive, or any value from 4.5 up to positive infinity, non-inclusive. Number 6, step 1, the whole side is being divided by negative 3, so let's multiply by it. It gives you 8 minus x is greater than or equal to. Notice I flipped it because I multiplied by negative 3. Now you have your shortcut option here. Since this is a minus x, what I would do is move it to the other side to change it to a positive x. But if you're going to do that, let's move 15 by subtracting 15. 8 minus 15 is a negative 7. But in order to get that x written first, you will have to flip-flop it around. The alligator is opening towards the negative 7, so make sure it continues opening towards negative 7. The next one, let's get rid of 5 by subtracting. Gives you negative 3 halves x is less than negative 1 minus 5 is negative 6. To get rid of a negative 3 halves, you're going to multiply the other side by negative 2/3. and you get x is greater, because you have multiplied by negative. Negative times a negative is a positive. 6 times 2/3 will be 12/3, which is 4. So there's the two parts of your answer. X is either these values, or x could be any of these values. So x could be any value less than or equal to -7. So x can be any of these values, or x can be any of these values. So that'd be any value from, let's scroll up, any value from -infinity up to -7 inclusive, or x could be any value from 4 up to infinity, not including 4. Okay, now let's talk about the other types, the and types. Okay, anytime you see the word and, here's what I want you to think: both. Because if something is an and statement, John is 13 and he has brown hair, that means that both qualities apply. He can't be just 13 and not have brown hair. Both must be true. So if we're looking at this inequality here, x is this stuff that is shaded. And notice that x is, here's my -2. X is values that are greater than or equal to -2, but not all values greater than, because these values over here are greater than or equal to -2, but they're not included. X is all values greater than -2 or equal to, and also both must be true. X is smaller. You see that this is 5. X is value smaller than 5. So x is greater than or equal to -2, and x is less than 5. Now, sometimes we'll write this as a sandwich statement. Let me show you what I mean by a sandwich. We'll put these two and statements together. Well, I believe that's actually what we're going to do in the next section. So bear with me and we'll talk about that in just a second. So we can write this in an interval notation, which is going to be pretty simple. That'd be all values from -2. We're going to start at -2 and we're going to go up to 5. So from -2 to 5, including -2, not including 5. So all values from -2 to 5. Because the solutions to an and inequality fall between two endpoints, they are frequently written in a more condensed form. And again, I call these a sandwich. Example, let's take the one from the previous example. We have x is greater than -2 and x is smaller than 5. Okay, so therefore the x value, look what I'm going to do here. I'm going to put the x value in the middle. And if you'll look at this part first, x is greater than -2. So I can flip it around and I can put x is greater than -2 in this direction. Now look at the second part. X is also less than 5. So sometimes we write it in this condensed version that says x. Look, this x right here is bigger than -2. That same x is smaller than 5. It's both bigger than -2 and it's smaller than 5. So really you can use the word, it's between -2 and 5. Okay, solving and inequalities. If the and inequality is written out, solve each part separately. If it's condensed like these were, you can solve it all together, working the inside out, and then we're going to graph to show all the possible solutions. So let's look at both scenarios here. First problem, number 7, we have 2x plus 3 is greater than -9. Solve it like normal. To get rid of plus 3, we're going to subtract 3. That gives me -12. To get rid of 2, we're going to divide by 2, and that gives me x is greater than -6. The other part, to get rid of -2, we're going to add 2. That'd be 8x is less than 32. To get rid of the 8, we're going to divide by 8. That gives me x is less than 4. This is an and statement. The symbol for and is an upside down union. So if you want to start using that for your and, that would be the symbol for and. So x is both. Now be careful here because both has to be true. X has to be bigger than -6. What I'm going to do is I'm going to do an open circle at -6, and I'm going to draw an arrow in this direction, saying x has to be bigger than that. But here's the problem. X also has to be smaller than 4. So the values that are bigger than -6 and the values that are smaller than 4 are the values from here to here. So that's what my solution looks like. All the values between -6 and 4. So therefore, here's how my interval notation looks. All values from -6 up to 4, not including -6, not including 4. Why didn't we include it? Because it's bigger than -6. Why didn't we include 4? Because we're values smaller than 4. Number 8. To get a plus 1, we subtract it. So we now have 2w is less than or equal to 10. Divide by 2 gives you w is less than or equal to 5. To get rid of the 1, we're going to subtract 1, gives you -5w is less than 40. We now divide by -5, so w, flip your symbol, is greater than -8. So we have an and statement. W must be less than or equal to 5, so any of these values, but it also must be greater than -8. So if it's bigger than -8, smaller than 5, that means it's between -8 and 5. So it's those values right there. Let me erase my arrows now. So that would be all values from -8 up to 5, not including -8, but including 5 because of the or equal to. Okay, number 9. Number 9 you see is written as in the condensed form of the sandwich, what I call the sandwich form. There's two different ways that you can work this. First off, know that anytime you see this sandwich form or this condensed form, it is always an and statement, okay? Which means both values or both conditions must be true. Now, one way to work it is to split this. Think of this as being, again, like a sandwich, where this would be like the meat in the middle, and then you've got the bread on the outside. And you can split this as the one piece of bread is less than or equal to the meat. And we also know the meat is less than or to the other piece of bread. So therefore, take the middle and pair it with this, and then take the middle and pair it with this. And then split it and write it as two separate inequalities. To get rid of -1, we're going to add 1. To get rid of -1, we're going to add 1. Since it's an and statement, you can actually push it back together in that condensed form, and you have -1 is less than or equal to a, and that same a is less than or equal to 7. So there's the condensed form of it. So that's going to be, here is -1, and it's really easy to graph when it's in condensed form. Here's -1, and here's 7. A is the stuff in the middle. The other method for solving these, which is much easier, the only problem is sometimes this other method will not work, and we'll run into that scenario down the road. Let's rewrite the problem again. And again, this is your shortcut. To get a by itself in the middle, we got to get rid of -1. But the only problem is you have three sides now. You have this, the middle, and this. To get rid of the -1 in the middle, we've got to add 1 to both other sides. So that gives us a -1 here. Bring down your symbol. Bring down your a in the middle. Bring down your other symbol. 6 and 1 is 7. So you get the exact same answer that you did here in a much quicker, shorter form. So that would be a would be all values from -1 up to 7, including -1 and including 7. Now on this one, we're just going to use the shortcut. To get p by itself in the middle, we got to get rid of +4. So we're going to do so by subtracting 4. Make sure you do it to both outsides. 0 is less than 3p is less than 15. Now you still, if you multiply or divide by negative, to move something, you do have to flip symbols. To get rid of 3, we're going to divide by 3. And that gives you 0 is less than p is less than 5. There's your answer. So open circle on 0, open circle on 5. P is the stuff in the middle. So P is any value from 0, let's try that again, from 0 up to 5, not including 0, not including 5. Number 11. To get rid of -2, we're going to add 2. Make sure you do it to both outsides. Gives you 30 is greater than -10m is greater than or equal to -5. To get rid of the -10, we have to divide by -10. Since you are dividing by a negative, make sure you flip both symbols. 30 divided by -10 is a -3. Negative divided by negative is a positive. 5 over 10 is 1/2. So that means that m is bigger than negative 3. So here is negative 3, bigger than negative 3, and smaller than 1/2, which is about right there. So that means that m would be the stuff in the middle. All values from negative 3 up to 1/2, including 1/2, not including negative 3. Get rid of the negative 2 first because the whole inside is being divided by multiplying. Turns this into a 10. Make sure you flip your symbols. You have 12 minus x. Make sure you flip both your symbols and a 4. Next up, let's get rid of the 12 by subtracting 12. 10 minus 12 is a negative 2, is greater than or equal to negative. I'm going to put a 1 in there just so you remember, negative 8. Now you actually have to flip those symbols again because now you have to divide by negative 1. Mark it out, and it gives you 2 is less than or equal to x is less than 8. So that means that x is, if you'll read it backwards, x is bigger than 2 and x is smaller than 8. So if you're bigger than 2, here's 2. Bigger than 2, smaller than 8, that means you are between 2 and 8. So that means you're all values from 2 up to 8, including 2, not including 8.